Okay, so starting out, we're going to look at first writing equations of circles. After we read through this, I'll have you fill in your graphic organizer for circles. So it says a circle is defined to be the set of all points in a plane that are equidistant from a given point in the plane called the center. Any segment with endpoints at the center and a point on the circle is called a radius of the circle. And here I just want to show you where the equation of a circle comes from. So it says, assume that the coordinates x, y, these are the coordinates of a point on the circle at the right. So we have the center, which you see for every conic section, the ordered pair HK will be a key part of the graph. So the HK for a circle is the center. XY is just some other point on the circle. And then also the radius is labeled here. They're just calling the radius r. It says you can find the equation of a circle by using the distance formula. So here I'm going to review with you what the distance formula is. So the distance formula between 2 points is the square root of x sub 2 minus x sub 1 quantity squared plus the quantity y sub 2 minus y sub 1 squared. So that's just a review of the distance formula. So what I'm going to do is I'm going to use the coordinates x, y as the x sub 2, y sub 2. So I'm going to replace x sub 2 and y sub 2 with just x and y from that ordered pair. And then I'm going to use HK as x sub 1, y sub 1. So I'll replace x sub 1, y sub 1 in the distance formula with HK. So, and I'm going to fill in that distance afterwards. So I would have the square root of the distance between those 2 points. So my x sub 2 is just x minus my x sub 1 is h. So x minus h quantity squared. Plus my y sub 2 is y, minus my y sub 1 is k, so y minus k quantity squared. And I know that the distance between those 2 points is the radius, so I know that's equal to the radius r. Okay, so how to get the equation of a circle? Use the distance formula, that's equal to the radius, and then solve for the, or rather not solve, but get rid of this square root by squaring each side. And you'll get r squared equals, and here the square root and this power of 2 just cancel out. So r squared is equal to the quantity x minus h squared plus the quantity y minus k squared. And if you flip that around, you can see it in this table. That is the most general form or the standard form for the equation of a circle. So the equation of a circle is really just representing the distance between the center and another point on the circle and saying it's equal to the radius. Okay, and circles, I know our review, or some of what we do with circles will be review from geometry. So this is our standard form. Center of the circle is the ordered pair HK, so if you have the equation of a circle, you can find what HK is to get your center. You can take the square root of what your equation is equal to get your radius. Or if you know the center and the radius, those are the 2 things you need to know in order to be able to write the equation of a circle. What is given here, the x squared plus y squared equals r squared, this is only the equation of a circle if the center is 0, 0. So hopefully that makes sense. If you replace the h and k here with zeros, then you would get x squared plus y squared equals r squared. So this is only if your center is 0, 0. This here is the most general form. This one is a very specific form. So we are going to include this information on our graphic organizer so that you have it for your assessments. So on your graphic organizer, you can fill in the box Here, write the standard form for the equation of a circle. So the standard form is the quantity x minus h squared plus the quantity y minus k squared equals r squared. And then I'm going to label on my diagram this circle that's graphed, that center would be at the origin. But the center of a circle is the ordered pair HK. And then you can draw in anywhere on your circle, but you can draw in a radius of the circle and just label that that's the radius, and we use R to represent the radius. So look at all the characteristics that parabolas have. Circles have too. You need to know the center and you need to know the radius in order to write an equation of a circle. You can be given other pieces of information to then find the center and the radius. Okay, but that's all we have to fill in for circles. Is everyone okay if I move this? Okay. So we're going to get right into examples. So we're first looking at being given different pieces of information to write an equation of a circle. So example 1 is more of an application. We have to then pull out the information and interpret what we're given to write our equation, but it says a certain Wi-Fi phone has a range of 30 miles in any direction. If the phone is 4 miles south and 3 miles west of headquarters, write an equation to represent the area within which the phone can operate via the Wi-Fi system. So what I'm going to do, because when you're trying to write the equation of a circle, your center is a coordinate, so I'm going to kind of graph the information I have or make a sketch of what this would look like on a coordinate plane. And mainly what I need to know, the coordinate that I need to know is the center. I need to know where that center is. So again, it's saying a certain Wi-Fi phone has a range of 30 miles in any direction. If the phone is 4 miles south and 3 miles west of headquarters, so what I'm going to do is assume that headquarters are at the origin, because then I can go along my graph. I can go 4 miles south, so from the origin I can go 4 units down, and then 3 miles west, which would be to the left. And I can say in relation to headquarters, this is where the phone is. Okay, so what ordered pair would the phone be at? By going 4 miles south and 3 miles west.
Minus 4. No, minus 4.
Yep, -3 and then -4. And then if I go back to that first sentence, the range of the Wi-Fi is 30 miles in any direction, which is going to create a circle. This is not going to be to scale, but I would have a circle around that. It's a terrible circle, so don't feel bad with what your circles look like either. So what is the 30 miles then? What part of the circle is the 30 miles? 30 miles then is the radius. So in any direction, that radius is 30 miles. Okay, and the phone then ends up being the center. So I have enough information to write the equation of my circle. So the standard form of a circle is x minus h squared plus y minus k squared equals r squared. So here my center is -3, -4, that's my hk. So I would have x minus -3 or x plus 3 squared plus the quantity y minus -4, which would be y plus 4 squared, equals The radius squared would be 30 squared. 30 squared is 900. So this would be the equation of the circle within which the phone could operate via that Wi-Fi system. Okay, so this is an example. Yes, we had to interpret what it meant, and in some ways we had to find the information, but we were given enough information to get the center and the radius right away. Questions on that example? Okay, so then example 2. Examples 2 and 3 are also writing equations, but you're given different pieces of information. So example 2 just says write an equation for the graph. It gives us the graph of a circle. We are given the center of the circle, which is -1, 4. And then we are given a point on the circle, which is -4, 6. Okay, so if I need to write an equation for the circle, I'm just going to write down the standard form. Circles are nice. They have one standard form. You don't have to figure out which standard form you're using. They're the only conic section that has just one standard form. So that is nice. So then from here, again, I need to know the center. I need to know the radius. I need to know h, k, and r. So I know the center. I know h, k. I'm given the center of -1, 4. So those I can substitute in. So I have x minus -1, so +1 quantity squared, plus y minus 4 quantity squared equals r squared. I'm not given the radius, so I don't know r. But I need to find r or find r squared somehow. And I am given another point on the circle. Ideas on how we can find r or find r squared using the information we have. Yes, for what? Yes, so your other point that you're given, you are given an x and a y coordinate. You have an x and a y in your equation. You can substitute those values in to then solve for r squared. That's one way to do it. Another way to do it, did anybody, I saw a couple of their hands. Was everybody going to say that, or were they going to say something different? Yep, you could also use the distance formula that we had written here, and you could find the distance between these 2 points to find your radius that way too. So there's multiple ways to do it. I'm just making sure whatever way you choose to do it is mathematically correct, but the way you do it, the way you get your equation, that's up to you. You just have to make sure that what you're doing makes sense. So I'm going to substitute in the -4 and the 6. So I would have -4 plus 1 quantity squared plus 6 minus 4 quantity squared equals r squared, and then I can solve for r squared. So I know -4 plus 1 is -3, and -3 squared is 9. 6 minus 4 is 2. 2 squared is 4. So 9 plus 4 equals r squared, meaning r squared equals 13. Now, I could go one step further and actually find r, but I don't need to because I have r squared in my formula anyway, so I can then just substitute 13 into my equation. So my equation for my circle is x plus 1 quantity squared plus y minus 4 quantity squared equals 13. So if you ended up taking the square root of each side to get r, you would just be squaring it back to get 13 anyway. So I wouldn't have to do that in this case unless the question specifically asked me for the radius, which it doesn't. It just wants to know the equation. Questions on that one? All right. And then example 3, again, is a little different. This one says write an equation for a circle if the endpoints of a diameter are 3, -3, and 1, 5. So here you are not given. You cannot just say, this is a common mistake I see. I see students just choose one of these points and call it HK. If these are endpoints of a diameter, neither one of these is your center. You can't just say one of these is HK and unless you know it's a center. So what I could do, just to make sense of this, is actually sketch these 2 points. So 1, 5, and then 3, -3. So endpoints of a diameter means these 2 points are both on the circle. Just kind of showing you that neither one of these is your center. Okay, but we're still trying to write the equation of the circle. I'm just going to write down the standard form again. So we need H, K, and R. We need to know the center, we need to know the radius, or at least find R or find R squared somehow. Ideas on how to find those two things. I'll say this, it's probably easiest if you find the center first. How could you find the center? Distance formula would be more so, because the distance formula would give you the length of the diameter. That would be more so used to find the radius, because that would give you the length of the diameter, and then you could cut it in half to get the radius. So that would give you the length of the radius, which we could do that first. We can do that without knowing what the center is. You would still need to find the center, so how would you find the center? Ideas. Just find the center? How? But you don't have places to plug both of them in, because neither one of these is HK. So you could only plug in one of them for X, Y. Grace? You don't need the slope. So kind of, Eli, you kind of said something. Where in relation to these points is the center? It's in the middle of them. Okay, your center's in the middle of those 2 points. Is there a formula that gives you the middle of 2 points from geometry? There is a midpoint formula. The center is the midpoint of your diameter. So here's a review of midpoint formula. Making sure I'm spelling midpoint formula correct. Okay. So midpoint formula, obviously it's a point, so it's a formula that is 2 coordinates, it's an ordered pair. Your x coordinate is the average of the 2 x coordinates you're given. So in the formula it looks like x plus 1, or x sub 1 plus x sub 2 divided by 2, the average of your x coordinates. And then your y coordinate is the average of the y coordinates, y sub 1 plus y sub 2 divided by 2. Okay, so the center is going to be the midpoint of the 2 endpoints of the diameter we have. So the center will be, using this formula, the average of the x coordinates 1 and 3 is 1 plus 3 divided by 2. The average of the y coordinates is 5 plus -3, or 5 minus 3 divided by 2. So we would have 4 divided by 2, so our x-coordinate of our center is 2. And then we have 2 divided by 2, which is 1. So our center is 2, 1. That's our HK. Okay, so I'm going to substitute those values in, we now know HK. So I have x minus 2 quantity squared plus y minus 1 quantity squared equals, I still don't know the radius, so I still have r squared. We talked about one way to find r using the distance formula, but now that you know the center, how could you find r?
Do the distance formula if you want.
Well, you could. So you could either find the distance between these two and cut it in half, or you could find, were you thinking using the center?
Yeah, using the center.
Yeah, you could also find the distance between one of these points and the center, or what we did in example 2. You just have to pick one of your 2 points. Now that you know HK, I can use either one of these. I don't need both. Just pick one. I would probably pick the 1, 5 because neither one of those coordinates are negative, so that's just my preference. Substitute those in for x and y and just solve for r squared like we did in example 2. So again, multiple ways to get r. It's just whatever way makes the most sense to you. You don't have to do it the way that I would do it. So if I use the coordinates 1, 5 as my x and y, I would have 1 minus 2 quantity squared plus 5 minus 1 quantity squared equals r squared. And I can then solve for r squared. 1 minus 2 is negative 1, and negative 1 squared is 1. 5 minus 1 is 4. 4 squared is 16. So r squared is 17. Again, I don't have to take the square root to find r. I will say this, if you're ever using the distance formula or you do end up taking the square root, don't ever give a decimal approximation in this instance, because then when you plug it back in to square it, it's again going to be an approximation, it won't be exact. So if you were to go a step further to find r, leave it just as the square root of 17. Don't give a decimal. So I just plug that back in. So my circle is x minus 2 quantity squared plus y minus 1 quantity squared equals 17. Now, on your assessments, one way or another, I will give you, because again, I don't want you to memorize formulas in this chapter. I want to know that you know how to use them and when to use them. I don't want you to get something wrong because you don't have the formula and you just forgot what it was. So I will give you the midpoint formula and I will give you the distance formula. I will either have them on the board, I will include them on the assessments, I'll give you a sheet that has them, because you're going to be writing a lot on your graphic organizers, and so I don't want you to have to squeeze those formulas in somewhere else. So don't write them on here. I will give them to you. Okay? You'll have to look in your notes for now to see them. All right. I have 2 more examples I want to go through with you. Example 4 will be quicker than example 5. Graphing circles, you might remember from geometry, really isn't too bad. So in example 4, it says find the center and the radius of the circle with the equation x squared plus y squared equals 81 and then graph the circle. So in order to graph a circle, it has to be in standard form so that you can find the center and the radius. This one already is in standard form. What would the center of this circle be? 0, 0. And then what's the radius? 9, the square root of 81. So here's how you graph a circle if you don't remember from geometry. You plot the center, and then usually what I'll do is I will go up, down, left, and right 9 units to get 4 other points, and then do my best to draw a circle through them. So if I go up 9, left 9, down 9, right 9. And then you do your best to draw a circle through those 4 points. As long as it doesn't look like a square or a diamond, it should not have corners. I'm not judging your circles too badly, but if you were to draw like a box, you're not going to get credit for that. It's clearly not a circle. So don't be too hard on yourself. The larger that the circle is, I think the harder it is to actually make them round. Yes, Cora. Your h and your k, x squared, y squared, because you don't have an x minus h or a y minus k. Yeah, so you'd have to find hk. But if you have x squared and y squared without like a quantity squared, they're both 0. Yep. Yes. Okay, then example 5. Example 5 is a little different because the equation is not in standard form. So you still need to find the center and radius of this circle. But to do that, the equation has to be in standard form. So I'm just rewriting the equation. And hopefully by looking at this and you look at your standard form on your sheet, you can tell this one isn't in standard form because you have the 4x and the 10y in there. And then you also have the minus 7. It's equal to 0. So here's where it will involve completing the square like we had to do for parabolas as well. So what you want to do is any constant terms like this minus 7, get that to the other side. So I'm going to add 7 to each side. But then also, I want to rearrange my x and my y terms. I want my x terms to be written together and my y terms to be written together. So I'm going to write the plus 4x after the x squared. So I'll write it this way, x squared and then plus 4x, then plus y squared minus 10y, and then I have equals 7 since I moved it to the other side. And once you have that, you're going to group the x's together and the y's together, and you are going to complete the square for both of these. So again, to go from something like this to just a quantity squared, we have to complete the square so we can factor it into a quantity squared. So I'm going to rewrite this. For the x's, I'll have x squared plus 4x plus some number. And then I'll have the same thing for the y's, y squared minus 10y plus some number equals 7. Now, if I'm adding two quantities to the left side, I have to also add them to the right side to keep it balanced. So I would have plus 2 quantities on the right side as well. Normally, for a circle, you will not have a coefficient in front of the x squared or y squared that you would have to first factor out. It's possible you could. Most of the time, like I said, for a circle, you will not. But make sure before you complete the square, whatever is in front of x squared or y squared, it's just a 1, or you have factored out if there's something else in front. So, again, how do we find these values to complete the square? What's the formula? B over 2 squared. So this value will be 4 divided by 2 squared, so that'll be 4. And if I'm adding 4 to the left, I have to also add 4 to the right. And then for the y's, I would take negative 10 divided by 2 squared. That's negative 5 squared, which is 25. So I have to add 25 to both sides. And then I would factor both of these, and they both should be a quantity squared. So x squared plus 4x plus 4 is going to be what quantity squared? X plus 2 quantity squared. And then plus, what about for the y squared minus 10y plus 25? Yep, y minus 5 quantity squared equals, and then I just add 7 plus 4 plus 25. So that's 11 plus 25, that's 36. That's the equation of my circle. Okay, this is the standard form. Now that it's in standard form, what is the center? What's H, what's K? Close? Negative, yep, -2 and +5. So H and K are the opposite of what they appear to be in the parentheses because it's x minus H and y minus K. So -2, +5, and what's the radius? 6. Okay, so plot -2, 5, and go up, down, left, and right 6 to draw your circle. So going up 6, you're going to be a little bit off the graph. That's okay. Do your best to draw the circle in. Okay, so really the graphing isn't too bad. Find the center, find the radius, plot the center, plot other points using the radius, draw your circle. Getting the standard form of the equation, though, depending on your equation you're starting with, that can be challenging. So there's one last example. I'll leave this on the screen, but there's one last example, example 6 on the back, that you have to go through like we did example 5, get the equation in standard form, and then graph it. I'd like you to work on example 6, and then I'll walk around, check what you have, answer questions you have. I'll pass out your assignment as well. But make sure you can get the standard form and graph it on your own.
You don't see the point. No. It's pointless. I know, I'm too fucking